Now let us solve some problems on Newton's law of cooling. Let's begin with the problem number 1. It states that a metal sphere cools at the rate of 3 degree per minute, right? A metal sphere cools at the rate of 3 degree per minute. What does it mean? Let's solve this. So the given data is what? Given data is what? Rate of cooling is 3 degree per minute. What does it mean? dt by d small t is equal to minus 3 degree centigrade per minute. Why write minus here? Minus here because cooling, because here cooling is mentioned, so because that I write negative here. Now when its temperature is at 50 degree centigrade, right, let's write that when its temperature is at 50 degree centigrade. Now it's saying a metal sphere cools at this rate when it is temperature. Okay, now this rating minus 3 degree per minute is when at temperature of the metal sphere is 50 degree centigrade. Now we have to find dt by dt is equal to at when the temperature of the sphere is 40 degrees centigrade, right? Because it's mentioned here, find its rate of cooling, means we had to find dt by dt at 40 degrees centigrade, means when the temperature of the metal sphere, that's T, is 40 degrees centigrade, if the temperature of the surrounding is 25 degrees centigrade. In both the cases, temperature of surroundings, that means ambient temperature, right, or room temperature is 25 degrees centigrade. Ambient is 25 degree centigrade, right? We had to find this, right, dt by dt. Now we know straight right away from the Newton's law of cooling, right, from Newton's law of cooling, dt by dt is equal to minus k t minus t ambient, right? This is what we found in the previous class. If you don't know, I will provide the link in the description where I have found this formula. Okay, I have very clearly mentioned about this formula and explained the concepts as well. You can, if you don't know, you can see the previous lecture. I will provide the link in the description. And yes, if you want to download the notes of this PDF of this video, no need to write that down now. Don't worry about notes. I will provide the notes link in the description also. Okay, right now just try, if you can, just pause the video, practice, and come back to the video, or just watch with full mind. No need to worry about writing. Okay, just worry about understanding right now. Anyways, we know dt by dt is minus k t minus ta, right? First we need to find the value of k, okay, because we are talking about the same body, right? This is the metal sphere. Its rate of cooling is 3 degree per minute when its temperature is 50 degree. Okay, at 50 degree temperature it cools down at 3 degree per minute rate, right? Now we have to find the rate of cooling of same metal sphere, right, at 40 degree centigrade. Since it is the same body metal sphere, therefore the k will be the same. Okay, so the k will be the same, and we don't know k yet, right? We have to find this. We know temperature is what, 40 degree, ambient temperature is 25 degree. But what about K? So we will find K from the previous data. That's condition 1. This was the condition provided here. dt by dt is minus 3, right, is equal to minus K. Temperature is what? 50 minus ambient temperature is 25, right? So what we get? This is equal to minus K. 50 minus 25 is 25. So we get K will be what? 3 divided by 25. Okay. So here we found the K. Right. Now let's use this K. So our formula, this becomes dt by dt is equal to minus 3 by 25 t minus t, right? Now what we have to find? We have to find dt by dt, right? This at t equal to 40 degrees and t equal to 25, right? So this is 40 minus 25, which is equal to minus 3 by 25 and 40 minus what? 25. Am I right? Yes, 40 minus 25. Now if you solve this, 40 minus 25 is what? Is 15, because 40 minus 20 is 20 and 20 minus 5 is 15, right? So we get minus 3 by 25 into 15. Now 5 3 is 15, 5 5 is 25. We get minus 3 3 is 9, minus 9 by 5, right? Minus 9 by 5. Now how much is that in? How much is that in fractions? Minus 9 by 5 is minus 1.8. Okay, therefore rate of cooling at 40 degrees centigrade is minus 1.8 degrees centigrade per minute, right? Because here it was, we use this per minute, so this is going to be per minute too. Okay, that's it. Now let's come to another problem. Okay, now what's the problem? Let's first write given data. A body cools, okay, it's cooling at the rate of 0.5 degree per second when it's at 50 degrees centigrade above its surroundings. Okay, the cooling rate of this body is, let me first write this, dt upon dt is equal to minus 0.5, okay, degree centigrade per second. I will not write that, we assume it's in degree centigrade per second, right? Is minus 0.5. Why negative? Because it's cooling when its temperature, when it is 50 degree above the surroundings. At, what does that mean? It means when you subtract the temperature of the body, this body, from when you subtract the surrounding temperature from this body, right, then it is 50 degrees centigrade. That's what it means when it is 50 degrees centigrade above the surroundings. What means is temperature of the body, say it's T, minus temperature of the surroundings, TA, T ambient or room temperature, is equal to 50 degrees centigrade. Okay, we are assuming it's in this 50 is in degrees centigrade. All right, now we have to find what is the rate of cooling when it is at 30 degrees centigrade above the same surroundings. We have to find dt by dt is equal at T minus TA is equal to 30 degree centigrade, right? Again, we know from Newton's law of cooling, dt by dt is equal to minus k T minus TA, right? Again, we are talking about the same body, so the k is going to be same, right? So let's first find the k, and to find the k we will use the data given. Here it is, dt by dt is minus 0.5, all right, is equal to minus k. T minus TA is 50, right? So I will write 50 here. So what is the value of k? K is 0.5 divided by 50, right? This is going to be 10 to the power minus 2. Okay, when you simplify this, like this is going to be 5 into 10 to the power minus 1 divided by 5 into 10 to the power 1, right? This 5 and 5 cuts. This is going to be 10 to the power 1 will go up and it will change into negative. Okay, so minus 1 and minus 1 will be minus, so that's why I write here minus 2. Okay, so k is 10 to the power minus 2, right? Now we know the value of k. Now what we are asked to find, we have to find the rate of cooling, right, at T minus TA equal to 30 degrees. So we know, let me get some space here. Okay, so we had to find dt by dt, right? This, so we'll use this formula again. Okay, what is going to be dt by dt is going to be what? Minus 10 to the power minus 2, right? Because k is 10 to the power minus 2 here. T minus TA. Okay, now we have to find dt by dA when T minus TA is 30. Okay, so this thing is going to be 30, right? And this is minus 10 to the power minus 2, so this is going to be uh, minus 10 to the power minus 2 multiplied by 30, right? This is going to be minus 0.3 degree centigrade per second. Okay, so let me write, therefore rate of cooling at T minus TA equal to 30 degree is 0.3 degrees centigrade per second, right? Because this here it was in this degree per second, and here it is 0.3 degree per second. So that's how we find the answer of this problem. Now let's move on to another problem. Okay, here is another problem. What's a body at 50 degrees centigrade? Okay, a body at 50 degrees centigrade means temperature, let T be the temperature of body, is 50 degrees centigrade. Okay, cools in surroundings at 30 degrees centigrade. All right, the temperature of surrounding, which we call as ambient temperature or room temperature, is 30 degrees centigrade, right? At what temperature will its cooling rate be half that at the beginning? All right, it's saying at which body temperature T is equal such that the dt by dt at this temperature is equal to half of the dt by dt at initially, right? T equal to 0, right? That's what is asked in this. Okay, now first let's find the value of K at T equal to 50, T atmospheric 30. What is going to be K? Now we know dt upon dt is equal to minus K T minus TA. Okay, let me change the color. It's going to be minus K. This is 50 and this is 30, right? 50 minus 30 is what? 20, right? All right, now we had to find dt by dt such that, now let's write this formula on left side and this side on the right side, because dt by 1 dt, this is a formula again. We will expand it in terms of this, and this again here will multiply half of and the expansion of this one, like this. Now first this, okay, it will be minus k T minus 30, right? Because ambient temperature is 30 is equal, now 1/2 of, right? Because here comes 1/2 of. Now dt by dt at T equals 0 means at T equals 0, what will be the temperature? T equals 0 initially is temperature is 50, right? 1/2 of minus k and 50 minus 30, right? Do you agree? Why we write the same k here and here? Because this is the same body. Now at T equals 0, what does that mean? See what is it? A body at 50 degrees centigrade cools in surrounding at 30 degrees centigrade. Okay, initially the body is at 50 degrees centigrade. Okay, this is the first temperature of the body, so this is the temperature at T equals 0. Okay, because T equals 0 is the beginning of our investigation. All right, so here what's going to happen? This k and this k, this minus k and this minus k cut, so we get T minus 30 is equal to 1/2 of, now 50 minus 30 is 20, right? 20, this is two ones and two tens, implies T minus 30 is what? 10, implies T is equal to 40 degree centigrade. So we found when the body temperature of this object reaches 40 degrees centigrade, at this temperature the rate of cooling will be same. Rate of cooling will be half of the as the rating in the rate of cooling in the beginning. Okay, you can also write it as never mind, therefore at T equal 40 degrees centigrade, the rate of cooling will be equal to half of the rate of cooling as in the beginning. All right, something like that. All right, so we found the answer to this problem. Let's continue to another problem. Here it is, we have problem number 4. Let's find its solution. Now what's asked? The rate of cooling of a body is 2 degrees centigrade per minute, right? Let me write that. The rate of cooling means dt by dt, right, is equal, now it's cooling, so negative what, 2 degrees centigrade per minute. Okay, we are assuming this minus 2 is means 2 degrees centigrade per minute. When at temperature equals 60 degree, the rate of cooling of a body is this at temperature 60 degree, means when temperature of the body means T, okay, is 60 degree centigrade. Also, and 1 degree centigrade per minute at 40 degree, and this dt by dt, all right, dt upon dt is equal to minus 1 degree per minute when T is equal to 45 degree centigrade, right? Now what's asked to find what will be the temperature of the surroundings. We have to find the TA, ambient or room or surrounding temperature. We have to find this. Now again, let's use that formula we know already, like we know dt upon dt. Let's use this first. We know, let me write here. We know dt upon dt is equal to minus k t minus ta, right? Now in this case, okay, dt upon dt is minus 2, so minus 2 is equal to minus k t minus ta. Okay, now t is what, 60 minus ta, we don't know, we have to find the ta. That would be equation first. Now here dt upon dt is minus 1, right? So minus 1 is equal to minus k. Why is the same k? Because we are talking about the same body. When t is 45 degree means 45, right? This is 45 minus ta. Ta we don't know, we have to find second. Now here you see, if you divide first by second, you are going to eliminate k, right? First divide by second or second by 5, because they are both this k and k will cancel out, so we are left with only one variable ta. Okay, now we have one variable and two equations, so we can definitely find the solution. Now let's do this. Divide. Okay, you tell me what to divide with what. Okay, let's divide first by second, right? What we get, 2 divided by 1 is equal to k, and k cancels out, is equal to 60 minus ta divided by 45 minus ta, right? Now let's cross multiply them. What we get, 45 multiplied by 2 minus 2ta is equal to 60 minus ta, right? Now let's simplify this here. 45 multiplied by 2 is how much? 90, right? Minus 2ta is equal to 60 minus ta. Okay, now let's take the 20 to the left and 2ta to the right. So 90 minus 60 is what, 30, and take this 2ta to this side, this will be 2ta minus ta is again ta. So ambient temperature has to be equal to 30 degree centigrade, right? Here we find the solution, so we can write the temperature of the surrounding is 30 degree centigrade. Very good. Now let's move on to another problem. Okay, now we have the last problem, I guess. Okay, let's first read the problem. It takes 12 minutes for an object at is it 100 degrees centigrade to cool to 80 degrees centigrade at room temperature of 50 degrees centigrade. Now what is it saying? It's saying it's taking 12 minutes for an object to go from 100 degrees centigrade to 80 degrees centigrade. I mean, say we have a body, right? Its temperature is something like this, 100 degrees centigrade, and its temperature drops to 80 degrees centigrade, and it takes 12 minutes. Okay, now keep in mind the room temperature is, all right, the TA is 50 degrees centigrade, right? Because it's mentioned here. Now the problem is, what we have to find is how much time will it take to decrease temperature to 70 degrees centigrade. All right, now 100, it is 12 minutes. Now it will decrease further to 70 degree centigrade, and here we have to find this time. That is the problem. Okay, all right, here is not clearly mentioned the rate. Yeah, although we can find the rate as this T2 minus T1, but I mean, say we don't need to use the Newton's law of cooling in the differential form. Okay, in these problems we can use the solution of the Newton law of cooling. Okay, that is I think you should know that this T, which is a function of time, this is temperature of the body, is equal to T ambient plus T initial minus T ambient multiplied by e to the power minus k t. Again, if you don't know about this, I have very well explained this formula, and it's really simple. Okay, you just have to watch the video lecture previously, which I will provide the link in the description, and you will get it, and you will find this is not something, you know, rocket science. It's very simple. Now first of all, let's find the value of k. Okay, we are talking about the same body, and we will use the conditions from this to this. We will use these conditions. Now here, from 100 degree to 80 degree, again the ambient temperature is 50. Here the ambient temperature is 52, by the way. Okay, so 100 to 80 ambient temperature is 50, and it takes 12 minutes to reach its temperature from initial temperature, right? This is initial temperature Ti to 80 degrees, right? So this we can put here 80 is equal to ambient temperature is 50 plus initial temperature is 100, right? Minus ambient is 50 multiplied by e to the power minus k multiplied by t. T is how much? 12, right? I think in this way we are going to find the value of k. Let's simplify it further. It means now 80 minus 50 is 30, I think, is equal to 100 minus 50 is 50 e to the power minus 12k, right? Okay, implies now 50, let's take 50 to the left, we get 30 divided by 50, right? So 0 and 0 cancel, we get 3 by 5. 3 by 5 is equal to e to the power minus 12 multiplied by k. Right, now let's take log on both sides. Okay, taking log on both the sides, what we get, log of 3 by 5 is equal to log of e to the power minus 12k, right? Now log and exponential will cancel out here, and log of 3 by 5 is going to be equal to minus 12k, right? 3 by 5. Now here we can find the value of k as minus log of 3 by 5 divided by 12. Now when you use the calculator to solve minus log of 3 by 5 upon 12, you will get k equal to minus 0.04256888. Okay, actually you'll get more. Maybe you won't write that too. 0198. Okay, such a big thing. Anyways, we needed the value of k and we got the value of k is minus 0 point. Okay, I'm not going to write it again, okay, because this is too long. This is the value of k. Okay, we found the value of k is this. Now since we know the value of k, we can use this formula again. Okay, t of t is equal to ta plus t initial minus ta e to the power minus kt. Now what we have to find? We have to find t is equal to decrease the temperature from 80 to 70. Now right now when we talk about these two, right, this is initial and this is final. Okay, likewise as we did in the before, in here cases, this was initial, this was final. Right now in 80-70, this is initial and this is final. Okay, so t initial right now is 80. Okay, t initial is 80. Ambient temperature is again how much? Is it 50? Yes, 50. Now this temperature is 70. Okay, ambient temperature is 50. We know the value of E. Now we know the value of K is this. Okay, now when you simplify this equation, because you know T, you know TA, you know TI, TA, E, you also know minus K. Now only missing thing is K, this T, right? When you will solve this, simplify this and use the calculator solving, because I have already solved this problem and I found t is equal to 9.5 minutes. Okay, therefore we can write here is 9.5 minutes, right? Now from 100 to 80, the time is 12 minutes. From 80 to 70, time is 9.5 minutes. Now if you will be asked the question, how much is going to be how much time will it take for this body to decrease the temperature from 100 degrees centigrade to the 70 degrees centigrade, right? What you will say, what you will do, because you know from 100 to 80 is 12 and 80 to 70 is 9.5 plus 9.5. That is the answer if it is asked in to find the time taken to decrease the temperature of the body from 100 to 70. But in our case, okay, we found the both ways. Okay, now it's 9.5 minutes, and when you add, you will get from 100 degrees centigrade. Anyways, that's it. Again, thank you for watching, and if you have any problems, you can contact me. I will provide my link, email, okay, in the comments or the description. And also, if you want the PDF of these problems on Newton's law of cooling, you can find the link again to download the PDF of this lecture in the comments, okay, comments, or in the description, or both, okay. I will provide the links in the both places. You can download from there. So that's it for this lecture. So see you in the next class. Thank you.